All right, section 1.4, measure and classify angles. We are going to name, measure, and classify angles. Some of what we do today will probably be a review of things you honestly saw way before, like middle school, maybe even before then. And that's fine, but we've got to just make sure we're all in agreement going forward. These are going to be skills we use for the rest of the year, terms we use for the rest of the year. So we already went through the warm-ups. Let's jump in to our fill in the blanks. An angle, that's what we're talking about today, consists of two different rays with the same endpoint. The rays are the sides of the angle. The endpoint is the vertex of the angle. We name angles using their vertex and points on the sides. Example 1 asks us to name this angle 3 different ways. Okay, now since we haven't talked about it yet, I'm going to kind of tell you those 3 different ways. First way is to name it just using the vertex. We do use a little angle symbol out in front of it. So, angle, what's my vertex? J. That's the corner or the end point that they have in common. Notice that they did not put a dot at J. Tried to warn some of you, at least, hopefully all of you, that there will not always be a point when you've got lines intersecting like that or rays intersecting like that. So you have to know there is a point there. The other way would be to name it using all 3 points. When we do that, the vertex has to be in the middle. So that gives us 2 options. We could have angle AJS. Or we could reverse it and have angle SJA. The vertex has to be in the middle. So when I name angles, I think about how I would trace along it with my pencil and name it in that order. Start at A, go to J, the vertex, then off to the side S. The vertex, we've talked about it a lot already. What is it? J. The vertex is a point, so we just put a capital J. If you would like to write out the word point, you can, but just putting capital J is fine. The sides. Our notes above said that the sides were made by what geometric object? Rays. So if we are asked to name the sides, we better be naming rays. So that means I'm going to put a little ray and another little ray. There are 2 sides. What is one of them? JA, good. Make sure you're starting at the end point. The other one would be JS. If I were to put ray AJ, is that the same thing? No, you've got to start it at the vertex. You can only name an angle by just its vertex, or just one letter. If it does not, share the vertex with another angle. So for example, on example 2, at no point could you tell me that you're talking about angle E. That would not make sense for this diagram because there are too many angles that occur at angle E. I won't know which one you're talking about. So example 2 asks us to name 3 different angles. Anybody come up with one? Kara?
AES.
AES would be one of my angles, the smaller one on top. Ariana? AET, that is the whole big angle. My last one. Brianna? SET, good. So we have two smaller angles and then the larger angle that contains both of them. We could have named any of these going the other direction. So you could have called it SEA, TEA, TES, but those would have still referred to the same three angles. We have now come to the part where I believe you might have seen this before at some point in your life. Acute, right, obtuse, and straight angles. Does anybody know the measure of acute angles? Paris? 45 would be an acute angle, but I'm thinking more general. Rodney?
30 degrees.
That's also specific. Kobe?
Below 90.
Below 90, but above 0. So they would be between 0 and 90 degrees. So yes, things like 30 and 45 work for acute angles, but anything between 0 degrees and 90 degrees. So we're not necessarily getting out protractors to draw these, but it should be some small looking angle. Anybody know the measure of a right angle? Matea? 90 degrees exactly. Nothing above, nothing below. Exactly 90 degrees. If you are thinking about a career in construction, I hope you're familiar with them. We use right angles a lot in construction. Now, this angle does not necessarily have to be pointing up and to the right. We could have right angles that would be flipped around some way, but it should be what we think of as a perfect corner. Okay, a 90-degree angle, a right angle. Does anyone know what symbol we will often see written inside right angles to identify them?
A box.
A box or a square, yes. So if you want to add that to your picture, go ahead. We usually see these little boxes in the corner to symbolize a right angle. Anyone know the measure of obtuse angles?
Oh.
Rodney, redemption?
Isn't like, no, never mind. I was going to say like 180 or something.
Well, you're on the right track. You're getting there. Any other redeemers? Majay?
Between 90 and 360.
Oh, close. If we combine you and Rodney. Maddie, sorry.
Between 90 and 180.
Between 90 and 180. Good. Between 90 and 180, that would be an obtuse angle. Okay, so generally these would be something like, we start off straight to the side, and then we're going to have this shooting off a little more to the left. Again, this is not the only possible diagram or picture for an obtuse angle. It's just one of them. What about a straight angle? Paris? Exactly 180 degrees. A straight angle is really just going to look like a line. It will have arrows on the ends. Sometimes you'll see a point in the middle labeled as the vertex so that you can talk about it. But a straight angle looks like a straight line, has a measure of 180 degrees. Use the diagram to find the measure of the indicated angles, then classify the angle. So when it says classify, it means acute, right, obtuse, straight. Those are our options. So they put a protractor here for us to use so that we don't have to fiddle with it. First, we're looking at angle WSR. Now, if I'm doing this on my notes, I'm taking a pencil and kind of tracing over that angle. Since I am lucky enough to be doing this on an iPad, I will highlight it for you. That's the angle you should be looking at. Start at W, trace down to S, go out to R. What is the measure of that angle? 60 degrees, good. Why would I not use that little number? Why would I know not to use the little number under the 60, Sydney?
It's for the other angles that are facing the other way.
Good, it's for the angles that would be facing the other way. Also, that little number down there, I believe it's a 120. Yeah, it's a little fuzzy for me. Okay, and this angle is definitely not obtuse, right? How would we classify it? Acute, so it wouldn't make sense to call it 120. All right, I'm going to erase my highlight so we can move on. The next angle is TSW. Start at T, go to the vertex S, and trace out to W. Okay, so this one, it's again landing on that big number 60. Hopefully we can see this does not have the same measure as the last angle. It's much bigger. Paris, what's this one? 120. This one uses the other number at the bottom. And how would we classify it? Obtuse. All right, I'll give you a moment to try to answer the other two on your own before we talk about them together, if you didn't already do so. All right, what did we get for the measure of angle RST? 180, and that would be a straight angle. Make sure if you're asked for the measure of an angle, you are putting a degree symbol on it. It's one of those nitpicky math things. That's our unit. So it should be there. All right, what about angle VST? VST, a couple people said it quietly. It is 90 degrees, which makes it a right angle. Thank you, loud and proud. All right, continuing on, we've got a new postulate, the angle addition postulate. If P is in the interior of angle RST, got a diagram to use here, then the measure of angle RST, that's what this little m stands for, measure of angle RST, is equal to the measure of angle RSP plus the measure of angle PST. Much like with segment addition, we can do the same kind of thing with angles. You take two smaller ones and put them together, you get a bigger one. If you want to make yourself a note about this little m stands for measure. That is notation that we will see used over and over again. These ones are pretty straightforward. Again, I would kind of trace over the angle that you're looking for or looking at. So we are trying to find the measure of angle RCO. Well, that's not too hard because they gave it to us. What is it? 63 degrees. All right, what about the measure of angle KCR? How'd you get 95 degrees? Good. You add the two pieces together, you get the measure of the bigger angle. Okay, what about OCY? 117 degrees, I agree. Again, add the two pieces together, And what about RCY? 180 degrees. We add all three of them together. All right, number 5 gets a little more interesting. We are told the measure of angle GFJ. So GFJ is the whole big angle. We've got some expressions written in for the two smaller angles, and we are asked to find them. So the first thing I'm going to ask you, do we think those two smaller angles have the same measure? No. Okay, they are going to have two different measures. We know that because they have two different expressions. So what are we going to do? Micah?
We put 4x plus 4 equals 155.
Not just 4x plus 4. Caleb?
You add the two expressions together and equal it to 155.
Good. We have to add the two angles together. So we want 4x plus 4 plus 4x minus 1, and then set it equal to the 155. Questions about why it was set up this way? All right, then, much like in our warm-ups, we need to combine like terms to help us solve for x. When I combine like terms, I should get 8x plus 3 equals 155. Subtract the 3 from both sides. 8x equals 152. Divide by 8. What do we get? 19. Questions about solving for x? Are we done with this problem? What do we need to do? Plug it in how many times? Twice. You could get away with once, but we'll talk about it. So let's plug it in first to the 4x plus 4. 4 times 19 plus 4. So the measure of angle GFH is equal to 80 degrees. We could plug it in again, or if we know the measure of the whole thing, and we know this one's 80, we could subtract. So we could take 155 minus the 80, and we would get 75 for the measure of angle HFJ. Now, if you were to plug it in to the 4x minus 1, that's fine. You should get the same thing. Oh, I should put my degree symbol on there. Questions, concerns? Warm, fuzzy feelings? No warm, fuzzy feelings. Cold, prickly feelings. Okay. Are we ready to move on? Yeah. Great. All right. This one I am going to let you try on your own. The only real difference here is that the directions tell us that we have a right angle. So we have to know that that means its measure is 90 degrees. Okay, so we should have taken x minus 4 plus 3x plus 2 equals 90. We add the two small angles together, set it equal to the big angle. Combine like terms. 4x minus 2 equals 90. Add the 2. Divide by 4. I'm liking 23. If we did not get 23, did we find where we went wrong? Okay, once we get 23, we still need to find the measures of the angles. what did we get for the measure of angle VRT? 19 degrees. Okay, and then we could either plug the 23 into the other expression or just subtract 19 from 90. We get the measure of angle TRS, 71 degrees. Questions, concerns about example 6? All right, we will keep this moving. Two angles are congruent angles. I'm going to use the symbol for congruent in that small space. If they have the same measure. Matching arcs or tick marks are used to show congruent angles or segments. Okay, so on segments, we usually see the tick marks or those little dashes that we've done before. On angles, we will see these arcs that you can see drawn in the corners. So if they have the same amount of arcs or tick marks, they are congruent. Knowing that, what is one pair of congruent angles that we see in this diagram? Deidreana? L and M. So because there are only one angles at each corner, we can just use the single letter. Angle L is congruent to angle M. What's my other pair? P and N. Angle P congruent to angle M. Now, if you called angle L angle PLM, and you called angle M angle NML, you can name these with 3 letters. That's fine. These two statements, I'll put them in a box. These two statements are the same thing. Okay, same thing. Just listed 2 different ways. Questions, concerns about naming those pairs? All right, on the second part of that, if the measure of angle P is 120 degrees, find the measure of angle N. Well, we just said they're congruent, so it ought to be 120 degrees. Questions, concerns? Moving on. If an angle is cut in half, it is bisected. Not really a brand new term, but we haven't done it with angles just yet. So we are told on example 8 that the ray WY bisects angle XWZ. Anytime I read that in my directions, I go ahead and mark those 2 angles as being congruent. I kind of stagger the arc marks so it doesn't look like just one big arc. And we're told that the measure of angle XWY is 29 degrees. XWY being the smaller angle here, 29 degrees. Find the measure of angle XWZ. So which angle are they asking for? Small one or the big one? Big one. So what are we going to do? Add them together or multiply by 2. Either way, we get it to equal. Okay, I hope somewhere in there were people saying 58 degrees. Questions, concerns? I would get in the habit of marking diagrams when you see them and you're given information about them. All right, our homework on your sheet again. Make sure you're paying attention. We do skip around a little bit on these sections.